Tectonic plate movements and a drop in sea levels once isolated the Mediterranean Sea from the Atlantic Ocean, causing the seawater to evaporate and form a vast salty basin. Previously, the Mediterranean transformed into a massive salt basin roughly 500,000 years ago. Evidence of this geological upheaval still exists today, and a similar event could potentially happen again in the future, according to IFL Science. Known as the Messinian Salinity Crisis, this event, according to researchers, occurred when sea level changes prevented the Atlantic from flowing into the Mediterranean, leading the sea into a near-total dry spell approximately 5.33 to 5.97 million years ago. Many scientists believe the Messinian Salinity Crisis occurred due to the discovery of a 1.5-kilometer thick layer of salt along the Mediterranean Sea floor, first confirmed in the early 1970s. However, not all scholars agree on the nature or scale of the event. One primary cause of the Messinian Salinity Crisis was likely tectonic plate movement. The African and Eurasian plates gradually collided over thousands of years, eventually causing a slow closure of the Strait of Gibraltar, a narrow waterway linking the Atlantic Ocean to the Mediterranean Sea. Another factor was the drop in sea levels, which made it difficult for ocean water to flow through the Strait of Gibraltar. A 2015 study pointed to a global sea level drop around this time linked to the expansion of the Antarctic ice shelf, which trapped more water in the southern polar region, far from the North Atlantic. The Mediterranean is especially vulnerable to such changes. Situated in a relatively warm and dry part of the planet, its seawater evaporates very rapidly. Without a water supply from the Atlantic, this enclosed sea dried up in just a few thousand years, leaving a salt-covered basin that connected parts of North Africa to southern Europe. Theoretically, one could walk from present-day Morocco to Spain or from Libya to Italy during this period. In fact, some animals migrated across these connections. Some Spanish islands like Majorca, Menorca, Ibiza, and Formentera were inhabited by land-dwelling animals during this dry period. Meanwhile, the crisis devastated the Mediterranean's marine biodiversity, wiping out 89% of the sea's endemic species. After a prolonged separation, tectonic activity reopened the Strait of Gibraltar, allowing a massive influx of Atlantic water into the Mediterranean. This event, known as the Zanclean Flood, was one of the most cataclysmic floods Earth has ever seen. Even today, the Mediterranean remains saltier than the rest of the Atlantic, due in part to the geographical and climatic conditions that once contributed to the Messinian Salinity Crisis. Though no longer isolated from the Atlantic, the Mediterranean has limited water exchange through the Strait of Gibraltar and experiences high evaporation rates, leading to increased salinity. A similar event may occur again in the future. Earth's tectonic plates are constantly shifting, and the Mediterranean region is particularly complex, with many unusual fault zones and overlapping tectonic fragments. As the African plate continues to move toward the Eurasian plate, the two could eventually merge into the supercontinent Eurafrica, potentially erasing the Mediterranean Sea from the map.